Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need to become a successful data scientist. Hope you guys are enjoying a lot. So we are enjoying and we are just having a proper understanding. So hope the same thing for you guys. So before coming to the session, please make sure that you guys have watched all the previous session videos so that you can have a clarity of what we are doing. Okay. So actually today's session is the continuation of previous session where we have just introduced you to the supervised learning and the types of it like regression and classification. Make sure you guys have watched the previous videos. So as mentioned earlier, this is a step, uh, I will say it's step 2. Okay, because like we have done everything related to data. Okay, data cleaning, DDA, and then we have gone through some coding part in or Python, like those things, and then SQL, and we have just so like these things are done, everything working on data is done. Now we are moved into the space where we are going to learn about machine learning problems. Okay, so yeah, so we have completed the introduction to machine learning, so like definition like those things, and we have just come to the point where we are just expressing what it is like supervised learning. It is one of the types in machine learning. Under that we will be having classification and regression. These things are we have done with the previous session. Today it's a continuation of previous session where we will be having something like a model training and evaluation. Okay, so training a supervised model involves feeding labeled data to the algorithm, allowing it to learn patterns and relationship. Okay, so as discussed earlier, let's fix the same example. Okay, because like I need to have a proper clarity. The entire thing should be same for me. Okay, so that's the reason I'm just we're gonna use the same thing. Okay, how are you gonna train the model means it's a simple thing, right? We're gonna have an apple and we are having a machine. We're gonna say it's an apple if it is in a circle color and red shape, red color, sorry, red color and circle shape. If it is a banana, it will be not in a circle shape and it will be in a yellow color. So the model gonna learn. So I'm saying the labeled, I'm labeling the data and I'm just feeding the feature. So that's it. Okay. And then the model gonna learn. That is what we will train the model. Training, the algorithm learns from the labeled data to adjust its parameter. Evaluation, the model test on the unseen data to access its accuracy and performance. Actually, number of times sir has mentioned this, right? So uh, why we are training the model, the only thing, the only output is we need to able to predict the unseen data. That's the end goal, guys. Okay, so that's a major thing that we are doing a model training. Finally, replacement, based on the evaluation result the model might be refined or retrained for better accuracy. The thing is, whenever we are not getting the expected accuracy, we need to go for training again, right? We need to tweak some parameters. These things we going to learn, guys. Don't take too much technical and don't get like upset. These things you guys going to learn in a depth match manner. Okay, so yeah, this all about how we train the supervised learning model. So yeah, sir, over to you.
Yes. So model training and evaluation, guys. It is, I'll say, same for all whenever you are training models and whenever you are doing evaluation. So after data. So once you've collected data from the right source as per the problem statement, and then you got data pre-processed, you did EDA and simple learning or okay, and now you have to evaluate, you have to train the model and evaluate. So training supervised learning model involves feeding labeled data to algorithm, allowing it to learn patterns and relationships. See, in supervised learning, you have to give the labeled data, and then we have to do training. The algorithm learns from the labeled data and adjusts its parameter. Okay. Evaluation, the model is tested on unseen data to assess the accuracy and performance. Okay, so evaluation is always done on unseen data, guys. So remember these terminologies. And refinement is based on the evaluation result. Whatever you have done the evaluation, what is the accuracy and performance? So you have to do refinement, go back, see where is the problem lying, where is the problem in the data, whether it is from the source? Is it connecting with the model? Is it have you chosen the right model? Okay. Have you pre-processed data properly? Okay. All those things you have to see. Is there any missing value, outliers? Okay. Anything. Is it biased? So all those things you have to see what is the problem. And based on that, you have to refine and reiterate for the better accuracy. Let's move to the other section.
Yeah, sure, sir. Yeah. So moving on, guys. Okay, we are having underfitting, overfitting, and underfitting. Actually, guys, I will say like you guys should have a, I will say 1000% understanding of this, because like using this only we gonna train our model and we gonna fix what is happening in the model. Okay, actually in the coding part also, I'm gonna show you the results, the exact results of the model overfitting sometimes. Okay, I'm not going to fine tune that, I'm going to show that to you. Okay, what is overfitting, then only you guys can able to understand, yeah, this is a way of overfitting. Okay, those things we're going to learn in a coding part itself. Okay, so yeah, what is meant by overfitting and underfitting? Overfitting and underfitting are common issues in supervised learning impacting model performance. Overfitting, the models learns the training data too well and fails to generalize to the new data. Okay, the thing is, if what is overfitting, we're having a model, you are training it. Okay, it knows all the things, 100% of it, and but it will fail for the new data because like it has memorized everything. Okay, consider, okay, you are having a book which has 10 questions, and you are just learning those 10 questions only, and you are done with it. Okay, it's a book and you are done with it, you are memorized all the 10 questions. When you go for the exam, the questions are asked related to the 10 question, not the 10 question. It is completely different, but it is related to that. But what happens means, since you have memorized all the questions, you are not able to answer anything. So that is, the model gets memorized the data rather than generalizing it, so it is not able to predict on the new data. That's it. Okay, now what is meant by underfitting? The model is too simple and fail to capture the underlying pattern in the data. That is, the model is not trained well itself, it is not able to train on the training data itself. So if it is not trained on a training data, how it can predict go for the testing? Don't consider about testing in underfitting. It is not working for the training data itself. That is, you are having a book and you are having 10 questions, you are not learning the 10 questions itself, then how will be going for the exam? Okay, so that's a major concept. Okay, just think of these examples and just understand this underfitting and overfitting. Like guys, I will say there will be no interview without this question. Okay, so that's a note, that's a point I want to say, and I will just pass it to the sir. Yeah, sir, over to you.
See, yeah, right. Overfitting. When, see, overfitting is just when model learns too much. Overfitting. Over. So you just understand the word. Remember the word over. It's like it learns over. Learns so much that it is not able to learn the actual unseen data, or it is not able to generalize. That is the problem. Like, have you heard word called overthinking? And somebody overthinks, he's not actually thinking on the generalized way. He's not actually balancing his thinking in a balanced manner, that there would be a probability, I'm thinking over, there would be a probability. Suppose somebody got headache and he starts thinking, oh, I might have some heart attack symptoms. That's overthinking. Like, similarly, data and model learns over, and that it is called overfitting. Like, it's not a balanced way. It is not able to generalize because there is no connection. I have a headache, I'll be having heart attack problems, right? But if I start overthinking, so that means I can think anything. So that's like, I don't have over control of my thinking. Same way, the model is like, overfitting because it's learned so much that it is not able to generalize. So it is not able to specifically see the patterns which it has to see. Okay, that is the main logic. So overfitting model learn training data too well, like too well, and fail to generalize the new data because see, there is a limited memory, there is a limited uh, it's not an infinite thing, guys, here. If it is infinite, our machines, our models are built infinite, then there won't be overfitting. Because ultimately it will get to a point and but the everything is limited. We can't suppose I'll tell you a overfitting problem. Suppose you have 1 liter of water bottle and you try to put 2 liters in it. What will happen? So it will overflow. So 1 liter already in the algorithm. I'm giving example. So how can that bottle, suppose that bottle is a model and you're putting data into it or something, it is doing magic, that model. So it will not it will not generalize, it will not predict what it is actually meant for. That is what is overfitting. Huh? And that will be seen. Now, what is the symptom? Why it will be overfitting? Because it would be biased. I'll say, see, I suppose I want 1 liter water and Raja wants 1 liter water. Okay. So what we did is I took 1 liter bottle. That's it. But I want that I'll have this 1 liter. Raja will not have. But I want to put 2 liters into it and I have already put 1 liter. Is it possible to put another liter in 1 liter bottle? And if I am not doing that, the data as it is the water with the molecules, which it is only for me, it is not for Raja. There it becomes unbalanced. So that is why, so if it is biased, it would be only my data, or it would be only X organization data, or it will be only Y, it won't be X data. Okay, so because I want it to be biased, and that is why model will not learn and it will not give you exact prediction and it will not generalize. Okay, now here if you have a data which is balanced, then what will happen? Overfitting will not happen. Data is from right source, it is not biased, okay, and it is pre-processed properly, it is collected from the right source as per the objective function of the problem statement, and then it won't be, the overfitting won't be there. Now, what is underfitting? Underfitting is when the model is too simple and fails to capture the underlying patterns in the data. See, again, if you have not your data is good, but your model is too simple, guys. The model you have chosen, yeah, you have built, okay, that is very simple and it fails to capture underlying patterns in the data. Okay. In overfitting, what happens that you are not given the data because or it is not going because it is trained so well. So both are abnormal activities in data, guys. Overfitting and underfitting. So I'll say both are outliers, both are anomalies. Why are there anomalies? Because data has anomalies, or model is not able to learn because it is too simple, or model learns too much because you have trained model wrongly on a wrong data. That is very important, guys, because data is not from the right source. Is it bad? Does it have anomalies, or it has biasness, or it is not from the right source, or it is not built according to the characteristics of your problem statement? So these abnormalities will happen: overfitting, underfitting. Suppose I'll give another example. Somebody is eating so much that he becomes 500 kgs, or somebody is so weak that he's not able to like he's like he looks like skeleton. So do you think both are balanced? No. We need to have as per our height and density of our bones, we need to have weight and height proportionally equal, so that is balanced body. Same way you need to have a balanced model which will predict rightly, which will perform well, and that is this is the difference. Overfitting, underfitting are both abnormalities in your model or data because of not having collected data from the right source, or not knowing which model to choose, or not building or training model properly. These things happen. Okay, so let's move to the other slide.
Yeah, sure, sir. So moving on, guys. Actually, this is also one of the important concept. Okay, I will say in the machine learning itself, it's an important concept. Bias and variance trade-offs. So bias and variance is a fundamental concept in supervised learning, balancing the accuracy and generalization of model. Okay, so we will see one by one. Okay, what is happening? High bias, the model is too simple and underfits the data. High variance, the model is too complex and it's overfit the data. Guys, now you can understand, right? High bias means it is underfitting. That is, the model is too simple. That is, we doesn't learn the questions in the book itself. Underfitting. High variance, the model is too complex and it overfits. That is, you memorized all the questions in the book. Okay, overfitting happens. High variance. Okay, optimal trade-off. Finding the right balance between bias and variance leads to the best performance model. That is optimal model. That is, you have learned you have learned the 10 questions and you have understand the 10 questions so that you can tackle any questions which comes to the knowledge that you have gained rather than memorizing. So you have optimally studied. That's the thing. The model is optimally trained so that it is not leads to the underfitting, overfitting, or high bias and low high variance. So we have reached the optimal trade-off. That is, we got an optimal model which is a best performing model. Okay. So guys, you need to think in a way that you need to get an optimal model based on your data set and based on your domain and based on your requirement. Okay, because like I will say 100% is not a good model, 95% is not a good model. It purely depends on the individual and the client need and the data set that we are having and what kind of domain is also. Okay, it's purely depend on everything. You should not say like I got 100% so like the model is very perfect. No, not like that. It depends on the data set, it depends on the domain, and it depends on how we train the model. Okay, yeah. So that's all about this bias variance trade-off. Yes, sir. Over to you.
Yeah, bias variance trade-off, guys. So I think I have explained it that if data is biased, or um, data, mainly it is data as per the problem statement, and the models you choose, and then the models you train and test, because it happens that way. So biased in model is too simple. See, why model will be too simple? Maybe you have not trained well the model, or you have chosen the wrong model, or your data has problem. There can be different problems, guys. So underfits the data. Model is too simple. So you need to understand. Variance, high variance. The model is too complex or fits the data. This is very, like, model is too complex. You've chosen the complex as per the problem statement. Suppose you have to choose logistic regression, you have chosen linear regression, or you have chosen your problem is categorical, and you thought that it is continuous. So now you can understand. It sometimes data is not problem. Sometimes the model evaluation, or you are not able to pre-process that data, or sometimes it will be that you have not taken data accordingly and you don't have a proper understanding, holistic end-to-end understanding about the problem. Okay, so it can be anything, but here high bias is because model is too simple that it underfits the data, and high variance is because it is too complex that overfits the data. Okay, so what is the best way? So optimal trade-off, finding the right balance between bias and variance leads to the best model performance. So you need to find middle path. So you would have known that Buddha ji has chosen middle path. He is not going to extreme X or Y. He will choose the middle path, right, straight path. That's called straight. Always choose the optimal and straight path, whether it is live or whether it is model selection. So don't go to extremes. The- Okay, if you go to extreme, you will be called leftist or rightist. You have to be a balanced person, who always thinks based on the current and the future goals, and decides. I'm talking about personal life. When you have a career or you have a personal life, so always think for the your 30, 40, 50 or 100-year goal, and then make decisions according to that, today's decisions. Okay, so always be balanced and optimal, and have that balance in whether it is career, choosing models, or your life. So have a balanced way, find the optimal way. Okay, let's move to the other slide.
Yeah, sure, sir. So moving on, guys. Like we're gonna see the applications of supervised learning. Hope, like guys, now you have a proper understanding. If you have watched the previous session and also this session, now you have a clarity of what is supervised learning. Okay. Hope you have watched both the sessions. Okay. So yeah. So applications of supervised learning. Supervised learning has a wide range of application in various fields, from healthcare to finance, revolutionizing how we analyze and interpret the data. First is self-driving car. You guys know about, right? Self-driving car is a supervised algorithm enables autonomous car to navigate roads and safety. Like I think we will be looking into like some different modules. Like that will be like this self-driving cars has different modules, guys. Not like you can just import and use self-driving car use. No, there will be different models, right? Like road detection, signal detection, object detection, different multiple things, case. So those and all comes under the machine learning and AML, and then it will just club everything, and then becomes lots of modules becomes self-driving car. Next is medical diagnosis. Supervised learning algorithms helps identify patterns in medical field, like medical data, improving diagnosis and treatments plan. Like the thing is, in medical field we can take a proactive decisions based on machine learning. Then spam filtering, this we know, like it is used to filter the unwanted mails and protect user from spam. So spam mail filtering, right? Actually, sir, in the previous session he has explained, right? There is a free. Okay, if the word free comes more often in a mail, then it's a spam mail. Like that, there will be some tax. Okay, so then personalized recommendation. So supervised learning algorithms powered recommendation system suggesting products or a content based on user preference. Yeah, this is a, I think this is what makes change to the internet itself, how we look into the intersection. Because like today we are getting what we like, how we are getting like that. Okay, I'm just teaching you guys data science. I'm every day I'm just getting a something related to data science, any article related to data science, any video related to data science, at least an ad every day I'm seeing without my knowledge. Okay, the thing is now we are getting whatever we like. The meaning is they are collecting a data in some manner. Okay, whatever the activity that we are doing, right? We are track. They are tracking us. Someone in the world tracking us and giving us what we like based on our historical data. That's all comes under this personalized recommendation. I hope, like guys, you can see, right? Today, like everything is recommendation. So recommendations, and it is recommending whatever we like based on personalized data. Okay, now you guys can understand, right, how much scope we gonna for this field. So yeah, this is all about the application of supervised learning. Yes, over to you.
Yeah, so application of supervised learning, guys. So let's focus here on supervised learning. Self-driving cars, we can use it. Uh, why? Why will use? Why we'll use supervised learning in self-driving cars? So can you write in the comment section? Because we know that why supervised learning is very important, because supervised learning, it will help us to navigate road safety. It is already supervised. Like when you are driving car, you're supervising it continuously. Every second of time your like supervisor is there sitting. Same way the algorithm, which is like there are algorithms which will be for autonomous vehicles, they would be actually supervising through cameras. Like you have computer vision, we use computer vision, and there will be high-end cameras which will be, but model will know each and everything. Okay, so it would be completely supervised, and also it will continuously learn. That is the best thing about supervised learning. Ultimately, because it's a machine learning, so it will continuously learn from the experience or the patterns or the data. Then comes medical diagnosis. Supervised learning helps to identify patterns in medical data, improving diagnosis and treatment plans. So it will find, suppose doctor sees some x-ray or some reports, he's not able to find something and he writes medicine, suppose 80%. But when machine diagnoses all those things, so it will give precise medicine, and it might also give a right medicine for the this treatment, or it will also, it might give a medicine which will, suppose some doctors keep giving medicines, keep giving for 10 years, 20 years, but maybe machine learning will choose a right medicine which will cure the person in 6 months only. He doesn't have to take medicine for 20 years. Because, see, in the medical, there's a lot of scam, guys. Doctors, medical representatives will go to doctors and they will influence through gifts, this, that, trips, this, gifts, that, gift. And they keep writing medicines to patients and their health gets spoiled, guys. I'm telling you, I have seen in real these things. So, but when we use AI, machine learning, guys, they will be non-biased because they don't want any gifts or any uh, anything. So they will give the right medicine so that the person gets cured in 3 4 months, and then that's it. Then he will give a proactive plan that what should you eat, this and that. So that, I'm saying, that's a long thing, that's a future thing, but at least it will be non-biased. Okay, but your data also should be non-biased, otherwise it becomes worse than doctor. So if it is biased algorithm and you create it, it is an again same thing which will happen. So then there is no difference. That's why ethics and ethical AI, ethical machine learning, ethical ethics in data science is very important. So spam filtering, I'll tell you, there are a lot of words which people already know that which words will be spam, but then there is always continuous reinvention and invention of new words. They check, okay, people use it on social media, people who do spamming, they will go and use these words, huh? Like you will find in stock market, overnight success, you earn this much, cryptocurrency, all those. So whenever you see such, they are very specific, like, or in gaming, you earn this, you must earn that. So whenever it is shortcut, it is a spam. So that is another way of looking at spamming, spam filtering. So you have lot of emojis, they have exciting, lot of text, not simple text, lot of patterns, not only the spamming words, but the behavior of an email. Some people just ask chat gpt write email, they will copy paste. So that is another pattern of spamming. So it keeps evolving. So as an AI/ML data scientist, we need to be aware about all these things. And personalized recommendation, we get supervised learning algorithms help recommend systems, suggesting products, and it can be used positively, guys, because personalized system, if it is trained on like showing the right product which has quality, then it's a very good thing, because you might be ending up doing low quality product, but the recommendation system, if it is built rightly with right data, right model, everything, then it will show you the right product so that you can have value for your money. So we can add lot of value through AI, ML, and data science and deep learning uh, to humanity based on using ethically AI and with right intentions. Let's move to the other section. Thanks.
Yeah, sure, sir. So yeah, guys, like this is what we are having for supervised learning. Actually, like we have introduced you supervised learning. What are the classification in the previous session? Today we have just gone through the underfitting, overfitting problem, bias, variance, students, like those things, and then we have looked into the application. Yeah, guys. So we have completed what is supervised learning, right? Now we will be moving on to the algorithms, and then we gonna have a alternative days of coding. Okay, you gonna see something which is very very unique, so very interesting, guys, for the upcoming sessions. So yeah, that's all about today's session. So guys, if you guys have any doubts, please make sure that you guys just mention in the comments. We will take it up, and we will make sure that the doubts are solved. And make sure to subscribe to our channel, because like every day we are posting a new video. Okay, because like it's gonna be a year long program. And make sure that you have subscribed to our channel and press the bell icon, so that you can have a like we can be updated with what whenever we are just posting the video. So yeah, that's from my side, guys. Please make sure that you watch all the videos, and your doubts are getting solved by us by putting everything in the comment section. So until then, next session. Bye, guys. Take care, and we will all meet in the next session. Bye, guys.
Yes, guys. So again, I'll reiterate, watch all the sessions 5 to 10 times, absorb the information, digest the information, and apply. Do all the assignments, and write in the comment section. Give us feedback to improve each session. So we'll be continuously improving everything. So keep learning deeply, have persistency, patience, consistency, have a long-term objective function for your career. Keep learning deeply, guys. That is the only way to become successful, because success is in every day, guys. You have to work hard every day, in and out. There is no, because life is continuous. It is not a discrete. It is not a one day. So you have to work each day of your life very hard, and learn it, especially very hardly. Lifelong learner. Keep learning, and you never know which learning will take you where. Just keep learning very deeply. And returns is, you when you join school in the first class, you never thought you will do graduation, masters, PhD, or whatever, and get a job. So always work for excellence, keep learning deeply, and uh, the money is result, the salary, the package, that is result. It is the result of your efforts you make. People can feel that. So just keep working very hard, learning very hard, so you'll be successful. Keep learning. Thanks.
Yeah, thank you.